Hi everyone! In today's video, we'll be showing you an example of how you can build an event-driven streaming application using DeltaStream and Superblocks. Superblocks is a low-code platform for developers to build internal apps and workflows. Recently, Superblocks announced their new Streaming Applications feature. A link to their feature announcement can be found in the description below. For this demo, consider that we are a credit card company and want to put together a simple streaming application to detect credit card fraud. Credit card transactions are produced as events into our Kafka cluster, and this will be the source data in our application. We'll first use DeltaStream to connect our Kafka topic and write long-lived SQL queries, which will detect if a credit card has been compromised. The results for the compromised credit cards will be written into another Kafka topic. Next, we'll use Superblocks to ingest the results topic and build a real-time dashboard that makes it easy for us to track which credit cards are compromised, and optionally perform actions such as send the cardholder an email or automatically suspend the credit card. Let's get started in the DeltaStream UI and navigate to the Stores tab. Notice that I've already added a store for my Kafka cluster called CC Kafka. We can list the topics and see the credit card email updates and credit card transactions topics. Let's inspect the credit card transactions topic and print some of the events. Next, let's go to the SQL tab and define relations for our data. First, we'll define a stream for credit card transactions. This stream definition mirrors the data in our Kafka topic that we just printed. The events in the stream include a credit card number, the amount of the transaction, and a timestamp for when the transaction occurred. Next, we'll create a changelog for our credit card email updates data. The data in this topic represents when a user updates their contact information with their bank. It contains the credit card number, the updated email for that credit card, and an event timestamp for when the email update occurred. We'll specify card number as the primary key. Now that we have our source data defined as relations, let's write a query to determine if a credit card is compromised. We'll consider a credit card compromised if there are 5 transactions with the card within 30 seconds. If your credit card is getting charged 5 times within 30 seconds, you most likely want to know about it and have your card suspended. Digging into the query itself, you can see we are using over-aggregation to count how many transactions occurred in the last 30 seconds for a particular credit card. We use a similar over-aggregation to find out the sum of the transaction amounts in those 30 seconds. Finally, we only care about credit cards that had 5 transactions or more in that 30-second interval, so we add a filter here. By submitting the query, we are launching a long-lived job that will continuously ingest data events, process these events, then output results into another stream. Now, with our first query, we have a continuous stream of events of credit cards that are compromised. Let's join this data with our email updates changelog to enrich our events with the email data so that we know which emails are associated with each card. This way, we can email our credit card holders when we notice their card has been compromised. Let's take a look at Stream 360 to see how our data is flowing at a high level. Using DeltaStream, we were able to transform our raw credit card transaction data into a stream of compromised credit cards. We then joined the results with the raw email updates data to produce a single stream of data that represents compromised credit cards with their associated email. Now let's hop over to Superblocks to build out our application using the data that DeltaStream prepares. Let's create a new application and call this application DeltaStream Demo. We have already set up an integration to our Kafka cluster in Superblocks, So let's use it to ingest our real-time data. We can do this by adding a new backend API, then choosing Control Blocks. The Stream control block is part of Superblocks' new streaming applications. Here, we can add the integration to our Kafka cluster. We'll choose Consume to ingest records from our topic. The topic we want to consume from is called Compromised Credit Card with Email. In the response block, let's choose Stream as the response type, since this is a streaming application. We can specify an on-message action for each event that is consumed from the Kafka topic. For the action type, we want to set state variable. We can manage our variables by clicking on the left-hand state icon. Let's create a new temporary variable called myVar and have it initialized to an empty array. Back to the onMessage handler, we can update the temporary variable each time a record is consumed from the topic. For each record that comes in, we want to append it to the myVar array. Let's build a quick dashboard with this variable so that we can see all the credit cards that are being labeled as compromised. We can drag and drop a new table component and set the table's contents to the myVar variable. Let's also change the title of our dashboard to Compromised Credit Cards. Now, if we run the API, we will see our compromised credit card data appear in our table in real time. Since this data is the output of our DeltaStream queries, only credit cards with 5 or more transactions in the past 30 seconds will appear. These rows also include the sum of all those transactions and an email associated with a card. At this point, we have built a real-time dashboard so that credit card companies can monitor which credit cards have been compromised as soon as possible. If we wanted to keep building out our application, we could add a processing block to our messages in our API or have other on-message handlers to do things such as send emails to our credit card holders or trigger actions for other APIs to automatically suspend their credit card. In just a few minutes, we were able to create an end-to-end event-driven streaming application using DeltaStream and Superblocks. If you want to try DeltaStream or Superblocks yourself, links to free trials of both are in the description.